Hello, everybody. I hope you're having a great day, and I'm very excited today to talk to you about enhancing ewe reproductive performance through improved management decisions. So we know that sheep are the world's third most plentiful food animal species at 1.2 billion head, surpassed only by cattle and chickens. They're incredibly important contributors to the global supply of food, uh, uh, nearly 10 million tons of meat and nearly 11 million tons of milk. Um, in addition, they produce a significant volume of fiber and hides. So sheep are very, very important in terms of aspects of global food security. One of the things that we know, we're living in a time where life expectancy is increasing. The number of people expected to inhabit the planet is expected to reach 9.8 billion, if not more, by the year 2050. And many estimates have told us that we're going to have a significant increase in food production of at least 50%, some estimates ranging as high as 100% increase from today, in order to produce enough food to feed the world. And given the sheep importance in food production, it's very, very important that we must improve production efficiency of sheep as well. So today I want to talk to you about management strategies that we can use to try to enhance sheep reproductive performance. And I'm going to approach this topic by breaking it down into four different components of reproduction. We know that the production of live lambs, whether it be by natural mating with the ram or assisted reproductive technology such as artificial insemination or embryo transfer, is going to necessitate that four distinct but yet interrelated biological events occur. The first of these is ovulation, to release that egg from the ovarian follicle. We have to fertilize that egg. We let that fertilized egg or embryo grow and develop and survive. And that conceptus is going to develop the fetal membranes, or what we oftentimes refer to as the placenta. And so that fetus has to grow and develop normally and survive the process. So let's start off talking about the first of these, ovulation rate. One of the things that we know is that ovulation rate sets the upper limit to prolificacy, because the incidence of monozygotic or identical twins in sheep is fairly rare. Scarevold estimated it's less than 1%. And from a common sense standpoint, we know that without ovulation, there cannot be successful reproduction, because this is the first step in the process. And so many breeds of sheep, and in many locations where they're raised, we know that sheep are seasonal breeders and they may be anovulatory due to that seasonal anestrus. But there may be other times in the life of that ewe where she does not ovulate. Maybe she is being underfed. Maybe she's in negative energy balance. There may be some disease which impacts her ability to successfully reproduce, and of course, other factors as well. So let's think about how can we enhance ewe ovulation rate? Well, we know that there's a myriad of factors that could play a role in influencing ovulation rate. And one of the important ones is the genotype or the breed. Now, we know that crossbreeding with the prolific breeds, such as the Romanov or the Finnish Landrace, is a very quick way for us to try to change the ovulation rate of our resultant F1 crossbreds. And so we know Gordon Dickerson and colleagues in Clay Center, Nebraska, when they were studying the Finnish Landrace, said that for every 1% of Finn genetics you infuse into a different eugenetic background, you can expect a 1% increase in the lamb crop percentage in that F1 crossbred. And so one of the things we know that there's an appropriate level of the prolific sheep genetics that you want to infuse to balance getting more lambs, but of the quality of lambs that you want for the marketplace. Dr. Dave Notter, in his review of the literature, indicated that purebred breeders do have the opportunity to implement some within breed selection for litter size. This is a much slower way to make change. You should expect no more than 0.02 lambs per year as an increase. But if you think about this in terms of a 40-year sheep production time period, theoretically, a person could be able to increase by 0.8 of a lamb. We also know that the age structure of the flock plays a role, that ewe lambs on average have a lower ovulation rate than yearling ewes, which on average have lower ovulation rate than 2-year-olds. And then once we get beyond 6 years of age, we know that there's the opportunity for ovulation rate to start diminishing. And many times that's driven not by the genetics of the animal, but because of some health conditions, maybe problems with the teeth, they're not able to graze as effectively, higher incidence of disease, so forth. We also know that for the sheep that are raised in locales where they are, in fact, seasonal in their nature of breeding, I pulled a study from many years ago. Dr. Clarence Hewlett was looking here in North America at measuring the ovulation rate of ewes every month of the year. And what is shown very nice in this graph is that during April and May tend to be the low point or the nadir of the ovulation rate. And then we start seeing the peak ovulation rate being up there quite often in this November, December time period. So one of the management strategies that we have is simply don't turn in your fertile rams for mating at the onset of the cyclicity of the ewe. Let those ewes go through a couple of estrus cycles to take advantage of that natural increase in average ovulation rate of ewes as they progress into the midpoint of their biological breeding season. We also know there's a very important nutrition reproduction interaction, and so providing proper nutritional management of these ewes and managing their body condition score is very, very important. And so many of you know about this body condition scoring system. It's been around for quite some time, but it's a system that basically describes the amount of fat cover that we find not only on breeding females, but breeding males as well. And there's a nice article by Kenyon and colleagues that shows some very nice color diagrams to help further emphasize this point. Typically, what we would do for our breeding stock is we would palpate them over the backbone and trying to feel that spinous process on the top, and then coming over to the side and looking at the transverse process. And excuse me, the body condition score system that we use for sheep goes from a scale of 1, which would be a very thin and emaciated ewe, to a scale of 5, which is a ewe which is very obese. Now, in an ideal world, we'd like these ewes at the start of the breeding season to be in a weight gaining condition, moving that body condition score from a 2.5 to a 3. The rams, of course, because we expect them to work a lot harder than an individual ewe during the breeding season, we'd like them to start the breeding season with a little bit of extra fat on their back, because a sexually aggressive ram is going to be losing weight during the breeding season. Excuse me. So we know this is a pictorial display of the body condition scoring system, showing that very thin ewe, that body condition score 1, that has basically very little fat over that transverse and spinous process. As we start working to the body condition score 2, 3, 4, and 5, you see progressively more and more fat being deposited subcutaneously on this ewe. And you get to the point where this body condition score 3, you can feel that spinous process, but you have to press fairly hard. And likewise, when you start feeling that transverse process, it's there, but you got to press pretty hard to feel it. And it feels very round rather than sharp, like we saw the transverse process on that body condition score 1. And then when we get to the body condition score 5, which I hope none of you ever allow your sheep to get that heavily conditioned, you can see that it's very difficult to even palpate the spinal process or the transverse process. And so whenever we see ewes like this in a intensively managed or semi-intensively managed, it's probably could be considered a nutritional mismanagement. Now we know in many pastoral production systems, particularly in locales where they have a dry season and a rainy season, there are breeds of sheep that have adapted to store a lot of fat in their tails and in their rumps just for the purpose of getting them through those lean times when the dry season is there and there's not a lot of forage availability. Now, directly related to managing body condition of this ewe is another nutritional management process called flushing. It's been around for a long time, and there's a fairly recent book chapter that's reviewed this nutritional management practice as a means of enhancing ovulation rate. If we look at the book of the nutrient requirements of small ruminants published by the National Research Council in 2007, doing a little bit of rounding, we know that we expect to feed about 50% more dietary energy and about 20% more dietary protein as a way of trying to increase the average ovulation rate of those ewes. And we recommend that we begin this supplemental feeding at least 17 to 21 days before ram introduction, maybe more if that ewe is in a really low body condition score. But it's important that you not continue for more than one ester cycle after the start of breeding season, because as we'll talk about later, it can have some adverse impacts on embryo survival. So the second step in this reproduction process of the ewe is fertilization of those ovulated eggs. And for a long time, we believed that fertilization in sheep was an all or none phenomenon, meaning that either all of the ovulated eggs are fertilized or none of them were fertilized. However, this hypothesis or belief has slowly been starting to prove incorrect across the myriad of breeds. And we know that there's been documented well over 1,100 different breeds of sheep across the globe. And so it should come as no surprise that not all the breeds are the same, but there's a growing body of evidence to refute that concept of all or none in terms of fertilization rate. And we do know that we should expect fertilization rate in excess of 90%, assuming, of course, that these ewes are reasonably well managed and we've got a ram who is not having any reproductive issues. And so when I think about fertilization rate, we know that there's two things that have to come together. We've got to have a good quality egg released from that ovarian follicle at the time of ovulation. And in addition, we need good quality sperm coming from that ram. And if either oocyte quality or sperm quality is deficient, of course, this is going to adversely impact fertilization. So what can we do to try to enhance our fertilization rate in sheep? Well, proper management is really important. Try to avoid heat stress, provide shade to those animals, which, and again, in extensively managed operations is challenging to do, but silvopastoralism, where we're planting trees and providing that shade. There are in many locales, people have portable shelters that they can drag around on skids to try to provide shade as they're moving from one grazing area to another. We want to try to avoid negative energy balance around the time of mating and try to avoid exposure to environmental toxins such as environmental estrogens, heavy metals that can particularly interfere with normal sperm production. And I would recommend, if you're working with a flock that has low reproductive efficiency, it's a pretty good idea to get a water sample and test that to see what contaminants may be there. But one of the tried and proven technologies that is something that everyone should adopt if they want to maximize their sheep reproductive efficiency is to put your breeding rams through a ram breeding soundness examination. Now, we know that this is a two-part examination of this breeding male. The first part is a general physical exam where we're going to look at structural soundness, particularly in the feet and leg area. You think about that ram mounting multiple ewes, depending upon whether it's intensively managed or semi-intensively managed, we may, in some circumstances, have as many as 150 ewes per one ram. And so he's going to be very busy and mounting and putting a lot of his own body weight on his rear legs when he's mating. And of course, common sense animal husbandry, we want to be sure that ram is free of any evidence of infectious diseases, because we don't want him being a walking source of infection, spreading a disease throughout our ewe flock. The second important component of this ram breeding soundness examination is the reproductive exam. We'll want to palpate the testes. We're going to want to palpate the epididymis, be sure that we don't have any outwardly visible signs of testicular problems or inflammation of the epididymis, disease called epididymitis, which can lead to subfertility or infertility. We'll want to measure the scrotal circumference. We're going to want to inspect the penis, particularly looking at that urethral process, or filiform appendage as it's sometimes called, to be sure that there aren't any stones blocking the urethra. And of course, we should ideally collect a semen sample and look at it microscopically so that we can know that we've got a good breeding ram. Now, here's an example of a reason why we would want to do a ram breeding soundness exam, is that we would, this particular ram shown here, we know that was, at quick glance, it looks like he's got, two testes in the scrotum and things, quick glance look good. But if you look closely, you can see they're kind of lopsided. And in fact, when you look at the testes from this ram, the one on the right was normal, the one on the left was atrophied. So it's really important during this breeding soundness exam to check for the symmetry between the left and the right testis. Go ahead and palpate and feel for the consistency. One of the things that I always like to do is make a fist and then squeeze my forearm muscle. And it's firm, but yet has a little bit of give. And that's what a normal healthy testis will feel like around the time of the start of the breeding season. We can push those testes down into the bottom of the scrotum and measure the circumference at the widest point. We know that that scrotal circumference is related to the volume of seminiferous tubules, which of course directly relates to sperm production capacity. And there's evidence that it also, if we start selecting rams for increased scrotal circumference, that those rams will produce daughters that reach puberty at a younger age. When we collect that semen sample, whether it be by artificial vagina or electroejaculation, we're going to want to measure the ejaculate volume. We're going to want to look at forward progressive sperm motility. We'll go ahead and kill a small subset of those sperm and do some live dead staining to look at morphology. And of course, measuring the sperm cell concentration with a hemocytometer, some other apparatus particularly important if we're going to be doing artificial insemination with the semen that we collect. And please keep in mind that our method of semen collection might, in fact, influence a little bit some of these parameters, but it will let us know that if this ram passes the breeding soundness examination based on his scrotal circumference and freedom of any palpable lesions, passing a semen quality exam, it gives us some confidence that that ram can get the job done. Now, when we think about embryo development and survival, one of the things that we know is that you can ovulate her eggs, that ram can get those eggs fertilized, but that embryo, that fertilized egg, has to grow and develop and survive if we want to get live lambs on the ground. And the classic paper that I have found that describes this in vivo pre and post implantation embryonic development were conducted at the University of Minnesota by Green and Winters back in 1945. And this is a wonderful publication, very descriptive in nature to let us see what is the normal progression of embryo development. And so you all know that the mammalian embryo, that one cell fertilized egg we call a zygote, that zygote undergoes mitosis to give us a 2-cell embryo. Each blastomere in that 2-cell embryo undergoes division. It'll eventually get to the morula stage. It finally undergoes differentiation at the blastocyst stage. We get 2 different populations of cells, the inner cell mass cells and the trophoblast cells. That embryo is going to hatch from its soft eggshell, so to speak, what we call the zona pellucida. It's going to go through a further differentiation event of gastrulation, forming those 3 primary embryonic germ cell layers of endoderm, ectoderm, and mesoderm. And that conceptus is going to form the fetal membranes or the placenta. And during this normal development process, this embryo, after it escapes from the zona pellucida, will be a very large spherical entity. It will undergo a change to a kind of a tubular structure and then filamentous. Excuse me. And as it's doing so, it's kind of staking out its territory, getting ready to attach to the uterus. And so this is what the sheep embryo looks like, the morula stage on the left, an expanded blastocyst. You can see how the zona pellucida, that outermost layer is thinner than what we saw with the morula. The overall diameter of the embryo is increased. And then the hatched blastocyst, this photo is taken at a lower magnification, but it does a really nice job of showing that single cell layer thick group of trophoblast cells. And around 3 o'clock, that dark group of cells, the inner cell mass cells, which will develop into the lamb, as well as many other tissue layers of the placenta itself. Now, one of the unfortunate things that we see in terms of embryo development is that there's an unfortunate antagonistic relationship between embryo development and survival and the ovulation rate. On one hand, we want to promote an increase in ovulation rate, but we know that the per embryo survival, as we go from a group of sheep with an average ovulation rate, with single ovulations, another group with all twin ovulations, the per embryo survival will start dropping as ovulation rate goes up. But if we assume a binomial probability of embryo survival, the good thing is that our resultant litter size, even as we go from 1 to 2 to 3 ovulations, our litter size is going to be going up. And at some point, we have to be a little bit concerned about uterine capacity issues. And I think most of the breeds of sheep that have been studied can quite readily handle 3 lambs being carried in utero. But of course, we also have to think about what's going to happen at the other end of the equation. Can that ewe support via lactation the rearing of three lambs? So in many environments, in fact, we don't want twin ovulations. We don't want triplet ovulations because if we don't have enough nutritional feed resources, we'd rather have 1 lamb and be able to keep it alive than having 2 or 3 and having all of those lambs succumb due to malnutrition. So what can we do to enhance embryo development and survival? Well, if we start looking at some of the factors that we know and have known in many cases for a long time that adversely impact embryo survival, one of them is feeding excess dietary energy in the immediate post-mating period. Doing so can lead to an increase in core body temperature and increased embryo death rate, which of course is not good. We've known for several decades now that there's a very important mineral called selenium, which has an important relationship also with one of the fat-soluble vitamins, vitamin E. And we know that we need to be sure there's adequate levels of selenium and vitamin E to try to reduce the likelihood of embryo death loss. And our colleagues from down under, or what they would say is the right part of the world, if you're from Australia and New Zealand, they've coined the term selenium responsive infertility because it's an infertility issue that you can make go away with proper selenium and vitamin E supplementation. So we recommend to producers to provide a trace mineralized salt mix that's been fortified with selenium and vitamin E. We know that here in the United States, the federal government regulates the amount of selenium supplementation. We can go no more than 90 parts per million of selenium in our trace mineralized salt mix. But I always encourage producers, read the tag on your trace mineralized salt mix. This is a picture showing livestock mineral where we can debate whether that's economically a good choice or not, or whether we can get the job done with a cheaper trace mineralized salt mix. But always read the tag to be sure that you know what you're getting and making that selenium vitamin E available through that trace mineralized salt mix. Another option we have is also to administer injectable vitamin E. Now, there may be issues of availabilities of this product and in extensively managed operations. Of course, it's impractical to catch the ewe to treat her with vitamin E. But this was a study that one of my graduate students did with Hampshire and Suffolk ewes, and we monitored the alpha tocopherol or vitamin E levels in the serum as we took the ewes off of pasture and put them into dry lot. And what this graph very nicely shows is if we inject vitamin E either by itself or in conjunction with vitamin A, we can maintain alpha tocopherol levels in the serum quite nicely. However, if we're not providing those injectable forms and not providing the supplementation through a trace mineralized salt mix, the serum levels of vitamin E will quickly go down. And so this is something that we need to be cognizant about of the pastures, the grasslands we may be using as the basis of the forage for mating. Do they have adequate vitamin E content? Now, heat stress is something that is very much known to adversely impact embryo survival. And this is something we've known for decades, in fact. And I pulled out a couple of very early studies that I think illustrate the point very, very well. One study, they induced heat stress for 20 days, 37.8 degrees C, and they were able to get a 100% death rate induced by that prolonged heat stress. In a different study that was done, the magnitude of the embryo loss that was influenced by the heat stress was dependent upon the timing of the exposure to that heat stress. And so they exposed ewes to a 32 degrees Celsius heat stress on the day of breeding or various days thereafter. And one of the things that they showed is that heat stress, that egg, very, very susceptible to heat stress. And the earlier the embryo, the more susceptible it is to heat stress. And we believe that part of that is at the time that the embryo undergoes its maternal zygotic transition for control of embryo development, and we start getting active transcription and translation from the genes of the embryo itself, those embryos can produce some heat shock proteins to provide some short-term thermal protection against heat stress. And so that's why we believe when we get out there, 5 days after mating, that embryo, excuse me, is a little bit more tolerant to the heat stress. But ideally, we'd like to try to avoid heat stress if at all possible. And of course, there's certainly some very strong genetic selection emphasis that's been placed on the development of certain breeds that are able to reproduce despite being in these very arid climates. So let's go on to the last component and talk about fetal development and survival. And when you go into the literature to try to talk about embryo death loss, fetal death loss, one of the frustrating things in the literature is the fact that different groups will make that cutoff of what's an embryo versus what's a fetus at different points in pregnancy. And I like to come back and look at what's going on biologically inside that sheep. And we know this developing sheep placenta is going to start adhering to the endometrium, that lining of the uterus, beginning on day 15. Yet the whole process of implantation, where that outermost layer of the placenta, interdigitates with the folds of the endometrium, is typically not complete until somewhere between days 50 and 60 of gestation. And so common sense will tell us until that implantation process is complete, that conceptus may be at a little bit more risk of something happening to that pregnancy. And so Boulay pointed out to us that fetal loss is influenced by the dam, by the sire, by the conceptus itself. When we start looking at the nature of the fetal loss, it may be complete, meaning we lose each and every fetus in that pregnancy, or there may be a partial fetal loss where we lose only one fetus or maybe one or two fetuses in a multiple pregnancy, but it's called partial fetal loss because we're still retaining at least one viable fetus. Now, there was a study done here in the United States by Dixon and colleagues that showed that more ewes lost one fetus and maintained then a partial pregnancy than all fetuses. And the proportion of sheep that lost all their fetuses was 20% in the singleton pregnancies, which I found to be quite high, but only 3.8% in the pregnancies carrying multiple fetuses. So yet other studies have reported reproductive wastage. They kind of said, we're not going to split hairs between what's embryonic loss and what's fetal loss. In a variety of flocks in this study, it ranged from only 1% to 5%. So clearly we see a lot of very significant differences from study to study in this concept of fetal survival. Some work that I was involved with where we were doing ultrasonographic fetal counting on a weekly basis starting at day 35, we observed that when that day 35 fetal litter size was high, we had a higher percentage of ewes exhibit partial fetal loss. And one could argue that perhaps this is nature's way of trying to get that ewe to only produce one or two lambs, because that's what she was designed to raise, with her mammary gland having only a left and a right teat. And so this is an area that clearly we don't understand a lot of the underlying mechanisms yet of how this happens. We also know that fetal loss could be induced by some of our management decisions. If we are doing pre-lambing shearing and we're coming in too close to the expected time of birth and the shear is a little bit rough. What my bigger concern is, however, is we know there are some disease-causing agents out there that will induce abortion. I've listed 3 of them, but this clearly is not an exhaustive list by any stretch of the imagination. So if we think about what can we do to try to enhance fetal survival, I think proper nutritional management is a key. We should do this fetal counting. We can segregate our ewes based upon the number of fetuses they're carrying in utero. That way we're not overfeeding some ewes, we're not underfeeding others. Of course, I'm very concerned about avoiding pregnancy toxemia, which oftentimes results in the death not only of the lambs being carried in utero, but the ewe herself. We should consult veterinarians in the area and find out what are the common abortion-causing disease agents in the area and vaccinate against those if there's a vaccine available in that locale. Try to shear before lambing. We know doing so can actually shunt some of the dietary nutrients to the fetus to help it grow a little bit better. But don't do it any sooner than 2 weeks before lambing, and don't shear before lambing unless you have adequate shelter to protect those ewes. And I think common sense tells us try to always avoid stress of those ewes, try to avoid any trauma. And I'd like to wrap up with a couple of thoughts related to genetic selection to try to alter litter size to improve our reproduction. We know that the field of genomics has been around for a while, and it's made its way into the sheep world. It's not just in cattle and some of our other livestock species. There have been a number of deleterious haplotypes impacting fertility, which have been identified. And so as we continue to study this more, we may have some genetic markers that we will want to try to select, be sure that we're not having those in our breeding population. There's also been a number of candidate genes have been identified, some of them influencing ovulation rate, some of them looking at oocyte development rate, some of them just looking at the litter size at the end of the reproduction equation. And so we know that there's great opportunities to learn more about these biological mechanisms associated with sheep reproduction and ways that we can positively influence them. And I think the greatest opportunity for further study is focusing in on mechanisms of embryo and fetal survival. And I'm very enthusiastic about implementing some of these new genetic selection technologies made possible by genomics, and doing that in conjunction with our well-established management practices, that's common sense animal husbandry. And if we start doing the right things, pull it all together, I'm confident that we can achieve our target goal for successful sheep reproduction. So thank you very much for your attention, and I will look forward to any questions that you may have.